Let's continue with this paper. Let's finish this paper. October, November 2022, paper 51. First three questions already done. Now we're moving on to question 4. So for question 4, let's just see what we've got here. A large population. In a large population, the systolic blood pressure, SBP, of adults is normally distributed with a mean. So I normally just write that down. My mean is 125,4, standard deviation 18,6. Very important to get our Z number, right? Find the probability, that which is basically phi, find the phi, that the SBP of a randomly chosen adult is less than 132. So I really can't do this without just having a rough sketch of where I am with my mean. My mean is 125,4. I want to see the 132 because then if I see the 132, I know I'm above my mean, and I know that the area that I'll be getting, if it is less than, will be perfect if I just read it off of the graph. I don't have to do complement or anything like that. So first things first, let's get our Z. Our Z takes the individual value that you're looking for, 132, minus your mean over your standard deviation. So let's just see if we're getting the same mean there. Oh, not the same mean. Let's just talk about the same Z. If you type in 132 minus that, what do you get? Should be getting, I'm going to borrow from there, is 3548, which is your Z. But be careful, that's not what we need. We need the probability. So you need to go and read off of your diagram. So if I can show you again how this little formula sheet works. 0.9, let's just remember to look. 0.3548. 0.3548. Let's go. There we go. 0.3548. So I'm going to add a 4, basically a 5. Like I can try and do like a number in between those. Let me just move along. So 0.3548. I basically want to add almost like a 16 or a 17, maybe an 18 to my last two digits. So let's see what they added to get to the one from the 0.63. Yes, I also get 0.63. And then if I go 0.6368, maybe they added a full 5, which is 19, 0.00000019. Yes. Yeah, if you round it, let me just show you what I've got here. Because the table does round it a little bit, you're welcome to use 0.35, and then I think they added a 19, and then they rounded off to 3 significant figures. But you know what I prefer doing? I prefer typing it into the calculator. So just make sure you're in stat mode. I'm still in stat mode at the top there. So then you just go Shift 1. No, you go Shift 1. And then you just go to distribution, which is Omni. Shift 1, which is, you want to go to distribution, which is 5, and then type in number 1. And then you don't need the table at all. But sometimes you need the table in reverse. So it's a good idea to know which way to read from the table. Sometimes we read it in reverse. So let's just see what that gives us. Yeah, it's sort of what I was getting from my table as well. So that means my phi, or my probability, is 0.639. Now we're going to do 3 significant figures, just like the memo did. Just check where you're getting marks from. Obviously the Z number calculation, and then it's just 1 mark actually for the final answer, 0.639, because you don't even have to do complement. Remember what I said from the graph that I drew, just to see where you are at. This is what we're getting, the probability. It's obviously less than, or actually more than 50, because remember in the middle there, that's always 50%. So that just helps me to orientate and see if the answer does make sense. If I wanted more than 132, I would have had to do complement. Okay, let's move on. The SBP of a 12-year-old of 12-year-old children in the same population is normally distributed with a mean, just write that down, mean 117. Of these children, 88% have an SPV of more than 108. Find the standard deviation. Okay, so again, this is going to save me. It's just quickly seeing the scenario. So if I'm looking at my mean of 117, they say 88% have an SPV of more than 108. So then 108 will be here. You can see because of the mean, and you can see because this area here is 0,88 or 88%. So it does help to just see where we are at, because we might have to use complement, we might have to use negative z's. Let's see what we can do with the formula. So z is equal to 108 minus 117 over standard deviation will equal your z number. But now be careful, this 0,88, as soon as it's probability, it's phi. So we need to, that's where the formula sheet helps a lot, is now, this is where we read in reverse, is we need to go and look for where 88% is going to be. 88, 0,88, that's pretty close. So I'm just going to think about this number for a second. So it's going to be 1,17. Let me just write that down, 1,17. But then I also might need to add a 10 there. I know you can't see the full page, but I do need to add to these last two digits. I need to add a 10, which means I have to use this number at the top 5. So 1,175 is what my Z number would have been. And just take this whole thing away. Is what my Z number would have been to get an 88% phi. So 1,175. Let's see how accurate we are by referring back to the memo. Yes. Oh, do you know why it's negative? It's negative because it's under the mean. So I was talking about it earlier and then I forgot to actually write the negative. So it needs to be negative 1,175. And with that, you just use normal maths and then you just solve standard deviation. 7,66. If you need me to help you with algebra, I can quickly help you with algebra. You would have times that side with a standard deviation, then you would have brought that over and then you would have gotten this number. Okay, that is then all they wanted for 3 marks. Let's move on. Three adults are chosen from this population. So just remember, 3 adults are chosen. Find the probability that each of these 3 adults has an SPV of 1.5 standard deviation of the mean. So that means they must be within, if this is your mean, they must be 1.5 this way or 1.5 that way. So they must be in this little barrier part that you've created for yourself. 1.5 this way and 1.5 that way. So what makes this easy is you know that how many standard deviations you are away from the mean is already your Z. So if you want to create maybe some simultaneous equations, you can say, let's just write that down. If my Z is equal to 1,5, I can then go and use my mean and my standard deviation from the previous page, or if you're lazy, you can use the memo with me. I'm going to use the standard deviation, remember, was 18.6, and the mean was 132. No, 125,4. Can I just write that down? I'm going to get confused. My standard deviation was 18.6. Let's just focus here. And my mean was, it's the same population. I just want to make sure. This population, yeah, because sometimes they catch you out with the words. 125,4. So just make sure you have your standard deviation and you have your mean. And now that you know that your Z is 1,5, it can help you to get your phi. So actually, now that I think about it, the standard deviation and the mean, you don't really need this because you normally use them to get your Z. All I'm going to do now, let me just recalculate my plan. All I'm going to do now is I'm going to check if my Z is 1,5, what will my phi be? 0,9332. Just check with me. 0,9332. So that means this area, maybe I should use a different color. Let's get into full teacher mode. This whole area up to 1,5 above the mean is going to be 0,9932. What did I do with my brain there? There's double threes and then 2. Hope you can read that. 0,9332, which I got from my table. That means this whole red area up to this point has got that probability. So then if you want to find this small little tail on either side, that side or on this side, you just do complement. So if you go 1 minus 0,9332, you'll get that small part that was excluded from the original area. 0,06. Why am I working this out? Let me just explain to you. You didn't want just this whole thing. If I can just draw another one here that's cleaner. You don't want this whole area. You want 1.5. Oh, let me just move you guys a bit. You want to chop it off here. You only want the part that's in between these two. So either you need to get this little tail piece there, or you need to get that little tail piece, but they are the same. So if you know now that that is the area where you do the complement, all you need to do is take your 0,9332, which remember is that whole red area, minus 0,0668. And then we'll see what you get there. Or we will use the memo. Yeah. 0, remember we're not done yet. I must answer the question first. So I just want to make sure that that works out. 0,9332 minus 0,0668 is this number. Yeah, 0,8664. So just remember that's the phi. And don't be worried if you also got distracted with, oh, I need the mean, I need the standard deviation. Sometimes you do need to go and check things that might not be relevant. So next time you don't use it so that you're quicker. But then what I want to ask you is, if 3 adults are chosen, think of a tree diagram. You want to choose an adult that has this probability 3 times. So if you're thinking about a tree diagram, you want to choose them, choose them, choose them. So you want 0,8664 3 times. You know, if you could have gone here straight away, but you could have also just seen a tree diagram in your mind, which means you can then, for 3 significant figures, 0,650. They say even 4 significant figures or better with probability, it's nice to be very accurate. Okay, I'm happy with question 4. That was a toughie. Then question 5. A game is played. Oh, we just need to read this together, right? Okay. A game is played with an ordinary fair 6-sided die. A player throws a dice once. If the result is 2, 3, 4, 5, the result is the player's score. Player does not throw the dice again. If the result is 1 or 6, the player throws the die a second time, and the sum of the 2 numbers will then be the answer. So if you draw a nice tree diagram, please don't make your tree diagram throw 1 and throw 2. That'll be terrible. So here, I must maybe just make some more space for myself because I know this one's going to be really big, and I know this one's going to be really big. Because if you throw a 1 or a 6, you have to throw again. So this one's not as important, 2, 3, 4, 5, but then this is why I wanted more space. If you threw this one, you needed to get 1, 2, 3, 4, 5, 6, and then you add that score 1, 2, 3, 4, 5, 6. I hope you're better with planning than I am because I'm writing into the words, but you get the gist of it now. Okay, so that is basically the tree diagram. Each of these probabilities, let's see if they want the probability on the memo. It will be 1 over 6, 1 over 6. Yeah, not a bad idea to show 1 over 6 on each one. Yes, on each leg. I know it's going to take some time, but I'm maybe not going to do it for everybody. But you know, each of these legs are 1,6 because that's the chances of throwing that on a dice, on a normal, unbiased dice. Okay, so the events A is a player scores 5, 6, 7, 8, or 9. Take any shortcuts here. What my suggestion is go and see which ones are 5, 6, 7, 8, or 9. So in other words, for 5, you have to go 1 over 6 times 1 over 6. Or I'm going to plus 1 over 6 just for this 5 straight. Then if I want a 6, I can go 1 over 6 times 1 over 6. That's how I get a 6 there. That's the only way to get a 6. And then to get a 7, I go 1 over 6 times 1 over 6. To get a 7, you do this top part, 1 over 6 times 1 over 6. And then I can also get a 6 by going 1 over 6 times 1 over 6, that root. Remember, each root that I take here, I must actually add them. Maybe it would be a good idea for you to also label what you're doing. This is to get a 5. This is to get a 6. This is to get a 7. To get an 8, it's also possible. You just have to go 1 over 6. So to get this first 6 and then 1 over 6 to obtain that scenario. Then to get a 9, which is still part of our probability, it's 1 over 6 times 1 over 6. So this is actually what I want you to do, is I want you to take all of these, add them together, and then we will see if we match with the memo. Yeah, that gives me 12 over 36, which gives me 1 over 3. Okay, let's do the next question. The next question, can we determine whether the events A and B are independent? For that to successfully work, you have to try and prove that probability A times probability B must equal the probability of A and B, like that. So we just worked out the probability of A is 1 over 3. So then we might have to go and check the probability of B. So to get the probability of B, I'm going to use their diagram. And remember, probability of B is working out that there is a second throw. So how many times will there be a second throw? It's all of these ones and all of these ones. So basically, if you throw a 1 or a 6. So I would say probability then of that's basically the same as what the memo said, 2 over 6 or 1 over 3. That's a probability of B. And now we need to go and try and compare that to probability of A and B. So the probability of A and B, maybe, okay, well, let's use the diagram. You want to have a second throw. So you want to have a second throw, but you also want the outcomes 5, 6, 7, and 8, and 9. So if you remember, maybe mine is better for the 6 and the 7. So that was 1, 2, 3, 4, 5, 6. 6 scenarios, 1 over 6, 1 over 6, 1 over 6. So 1 over 6 times 1 over 6, we're doing that how many times? 5 times. 1, 2, 3, 4, 5, 6. So now I hope I'm not confusing you guys at all. That gives me 6 out of 36, if you remember how many of those scenarios we counted, which reduces down to 1 over 6, whereas this one reduces down to 1 over 9. So if you see that these are not equal to each other, just check on the memo. 1 over 9 is not equal to 1 over 6, so they are not independent. Important to make that classification there. Okay, let's go on to the next one, and which is also our last question. Question 6. It's when we start having to combine committees. So I hope your brains are switched on. Oh, did I miss question 5D? It looks like I did. Let's quickly go back to 5D. Probability of B given not A. So you probably already saw the formula now. Probability of B given not A. So the formula is probability of B times probability of A. Ooh, no, it's and. I'm starting to lose it a bit here. And not A over, and then I would like probability of not A. So I think the easiest one here is to get not A because we did previously get A. So not A is 2 over 3. 2 over 3. And now we just need to go and find probability of B and not A. So we just have to go find the other scenarios. So if you go and count, remember the ones that we used last time? We used this one, this one, this one, and we used that one, that one, that one. So the ones that we didn't use is going to be all 3 of these and all 3 of those. So it's again the same as what I did here. There is basically 6 of the 1 over 6 squares that I basically pick to be in scenario B and in scenario A. What I mean, not in scenario A, which means you have to have a second throw, but you do not have to get the numbers 5, 6, 7, 8, 9. So if you do this little formula, let's follow from the memo, you get 1 over 4. But it was important to use the table again to get to that 6 over 36. Okay, let me try and wrap up this last question. Social club has 15 members, of whom 8 are men and 7 are women. The committee consists of 5, or the committee for the club consists of 5 of its members. So it's a social club, but we need to, from the social club of 15 people, pick a committee of 5 members. Find the number of different ways in which the committee can be formed from the 15 members if it must include more men than women. So more men than women, I could have all men, right? Or I could have, remember there are 5 there. So I can also have this scenario where it's 4 men, 1 woman, or I could have 3 men, 2 women. So those are the only scenarios where there are more men than women. So if you want to check the way to do this after writing down the scenarios, you just need to basically from the 8 people to choose only men. You're going to go 8 choose, and then if it was men only, you can say 8 choose 5. And to do 8 choose 5 will help you to get men only. So of the 8 men, you choosing 5. That's this scenario done. Then I'm going to add, what if we take the 8 men, but we only choose 4, and then we take the 7 women and we choose 1. Then we've got this scenario sorted. And then I'm going to add 8 choose 3, which means I'm 8 men choosing 3 times by then the 7 women, and I choose 2. So I just need to hurry up a bit because this video is getting a bit long. Then you'll get 1722. I feel like that would be the easiest way. For me, you could have done complement if you really wanted to. Then for 6B, 15 members are having their photograph taken. They stand in 3 rows with 3 people in the front row, 5 people in the middle, and 7 in the back. So 3 people in the front, 5 in the middle, 7 in the back. In how many different ways can the 15 members of the group be divided into groups of 3, of 5, and of 7? So remember to choose the people, let's follow with the memo. Which group are we going to choose first? Let's maybe choose the front group first. So I'm just going to explain from there. 15C3 is telling you we choose the front group first. 15C3, then those people sit down. Then how many people are left? 12 people are left. Now I want to choose 5 people to sit in the middle. Now there's only 7 people left, and I choose from that 7, the 7 people at the back. So that would be the easiest way for me to do that question. And then in between, obviously, you just times it. And it is not probability yet. It is permutations. How many ways can you do that scenario? Okay, that was question 6B. Now question 6C. In one photograph, Abel, Betty, Callie, Doug, Eve, Freya and Gino, these are the alphabet, are seven members in the back row. In how many different ways can the seven members be arranged so that Abel and Betty are next to each other and Freya and Gina are not next to each other? Let's first make sure that Abel and Betty are next to each other. I call this the rubber band theorem. If Abel and Betty are together, then remember the other people are still loose like this. So if I had to choose the first person to sit here, I can choose this group or any of those. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 6 factorial is basically what I've got to choose from then. 6 factorial, and I'm running out of bed. 6 factorial. And I need then Abel and Betty can swap in between each other. So you can say 2 factorial or just times by 2. That'll give me all the scenarios where Abel and Betty are together. The problem is inside these possibilities, there are still possibilities where Freya and Gino are together, and we do not want them to be together. So we want to basically minus the scenarios then where they are together. I hope that's not too confusing. Abel and Betty together, definitely. But now I'm going to minus the scenarios where Abel and Betty are together and Freya and Gina. So what I'll do here is how many groups do I have now? 1, 2, 3, 4, 5. 5 factorial. But they can still swap inside each other and they can still swap inside each other. So then I minus the scenarios where Freya and Gina are together so that I'm basically using like the complement. So my answer there is 960. Sorry, I hope I wasn't rushing too much at the end there, but I feel like that's a wrap then for this whole paper. Remember, it should take you an hour, 15 minutes to complete a full paper like this, and it counts 40% to your AS and 20% to your A levels. I hope it was a successful session. Good luck.